Hi, this is King of Review. Here we need to expand x squared minus 2y, all raised to the sixth power, to find the coefficient of the term with x to the sixth and y cubed in it. Multiplying this binomial by itself 6 times would be difficult and time-consuming, so there's a nice shortcut called the Binomial Theorem, named because this polynomial, x squared minus 2y, is a binomial. It has two terms. Now, there's an actual statement of a theorem that gives us sort of a formula to work with, but it's a bit of a complicated formula, especially when you have multiple exponents in the problem. As long as the power that we're raising our binomial to isn't too large, like 6, there's a nice shortcut for the binomial theorem called Pascal's triangle. And it works like this. We're going to make a triangle of numbers. I'm going to start with 3 ones, making a triangle already. Then for the third row of the triangle, I'll start and end with 1 again, but in the middle, I'm going to add up the two numbers above. 1 plus 1 is 2. I'll do the same thing on the next row. Start with 1. 1 plus 2 is 3. 2 plus 1 is 3. And end with 1. On the next row, start with 1. 1 plus 3 is 4. 3 plus 3 is 6. 3 plus 1 is 4. And end with 1. I could keep going. 5, 10, 10, 5, and end with 1. 1, 6, 15, 20, 15, 6, and 1. Now I'm going to stop there, and here's why. These numbers are coefficients of expansions of binomials. The first row is the coefficient if you raise it to the 0th power. The second row is raising it to the first power. Then we have the second power, the third power, fourth power, fifth power, and sixth power. And that's the power we want to raise our binomial to. So Pascal's triangle tells us we will have 1, 2, 3, 4, 5, 6, 7 terms. And these are the coefficients. 1, 6, 15, 20, 15, 6, and 1. And they'll all be added together. To fill out the rest of each of these terms, we go to the actual binomial. The first component is x squared. So in the first term, I'll have x squared to the sixth power, since that's the power we're raising our binomial to. The next term goes down by 1, x squared to the fifth, then x squared to the fourth, x squared to the third, x squared to the second, x squared to the first, and finally x squared to the 0. For the second component, negative 2y, we go in reverse. Negative 2y to the 0, and then we go up by 1 from there. Negative 2y to the first, negative 2y to the second, negative 2y to the third, negative 2y to the fourth, negative 2y to the fifth, and we end with negative 2y to the sixth. Now I'm focused on the term where we have x to the sixth, y to the third, and that's going to happen in this term here, since when you raise something to a power and then to another power, for example, if you have a to the b power to the c power, that's the same thing as a to the b times c power. So in this term, x squared, then to the third power, will be x to the 2 times 3, or 6. So we'll have x to the sixth, and we'll have y to the third. So let me focus on this term here. It's 20 times x to the sixth times, now we have to distribute the 3 to both parts of the parentheses, negative 2 to the third times y to the third. Negative 2 times negative 2 times negative 2 is negative 8. So if I rearrange this problem, I have 20 times negative 8 times x to the sixth y cubed. I want the coefficient of this term, so that's 20 times negative 8, which is negative 160. And there's our answer. Thanks for watching.